and welcome to SSW TV. We're at NDC Sydney and I'm here with Gojko. Welcome,
Hey.
Gojko. Hey, so in the technology space, what's got you excited at the moment?
I think the most interesting thing happening at the moment is this whole serverless or cloud functions revolution that's happening, and I think it's completely changing the landscape of software architecture and what people are going to be doing in 10 years' time.
Awesome. Why do you think it's a big deal?
It's a big deal, I think, because it's the first time that economics are pushing people to do good architecture.
Wow, I've never heard it explained like that. Cool.
So lots of people talk about serverless or kind of cloud functions. Oh, you don't have to maintain this, you don't have to maintain that. That's all fine. It's brilliant, it's fantastic, it's one of those good benefits, but I don't think that's where the big revolutionary thing comes in.
Can we jump back and go, can we give the audience, so what's the short version of what serverless is?
The short version of what serverless is you create a piece of code that's a function, and then you let Amazon run that function based on some event. For example, a message going to message queue, or a file being uploaded, or a certain step in a workflow being reached where people are no longer, with the serverless architecture, you don't have to think about applications anymore and running applications inside virtual machines, scaling that up or down. You just define what happens as a reaction to an event, and then Amazon takes care of scaling up and down, monitoring, managing, restarting, and things like that. So the big shift is, if you think about something like App Engine, or I think Azure calls that Azure Apps, or Heroku, where you have an app and then the app is a website. You say, well, this runs on five instances, and things like that. And if those 5 instances are not doing anything, you're still paying for them. If you have 20,000 people coming to your website, those instances need to scale, and they'll scale automatically, but then when do they scale down? How do they scale down?
But you're still thinking about how many instances
there are, where in this case, monitoring, provisioning, restarting, starting is magically done for you. So that's kind of technically the next step in this cloud evolution, but I don't think that's why it's important. I think why it's important is the economics of it are for the first time giving teams incentives to do architecture right.
So explain that a bit more.
Here's a really interesting thing to think about. For 20 years, people have been saying how small, independent modules are good.
Yeah.
How you should limit your risk by doing kind of, a bit of unit testing, looking at that, and then kind of thinking about independent modules, object-oriented programming, functions. All of it is going in that direction. And then you have a single machine, and that machine needs to run your code. So you bundle everything together. And it's all interdependent. So going to cloud, you have VMs, but then kind of with VMs, effectively, you not change the incentives. You rent a VM from Amazon, that VM better be busy. For example, I'm working on a collaboration tool at the moment, and we can export the document to multiple formats. PDF is a memory hog because of GhostScript. SVG, text file transformation, almost no memory needed. But we have 30 different types. I'm not going to start 2 VMs for each of those types. And you need 2 VMs, you need failover, you need scaling, you need... So if I wanted to keep it properly separate, I need 2 or 3 VMs for each of those types, where when it starts ramping up, I need to start scaling. I'm not going to pay for that. So what I do is I put it all on a queue. I have a queue listener that kind of runs on a single VM and does PDFs and SVGs. And then we have a situation where the PDF is a memory hog, it gets stuck, it disrupts SVG, disrupts all the other stuff, because the economic incentives are pushing me to bundle things together. Now, with Lambda, you pay per usage.
And Lambda is the Amazon implementation.
Lambda is the Amazon implementation, but again, Google calls it cloud functions, Azure calls it, so it's not, Lambda is just the first to come along, so I'm using Lambda, I'm calling it like that. But the thing is, you pay per usage, and you pay for 100 milliseconds in the processor. With Heroku, with Azure apps, with App Engine, you pay for an instance, and you pay for an instance per month. When you have that instance, you're going to run it. You pay for hours. If you rent an EC2, you started for 10 seconds of something, you have it for an hour. You better keep it busy.
Yep.
There's no point shutting that down. And with Lambda, you pay for 100 milliseconds.
Yeah.
And that means that if we have a request coming for an SVG, we pay for 100 milliseconds of that, and that's brilliant. Now, it's the first time in deployment infrastructure where I'm being penalized for bundling the PDF exporter and the SVG exporter together. Because you're paying for 100 milliseconds times the memory you've taken.
Yep.
Now, if I have a VM that combines memory-hungry stuff with stuff that's not memory hungry, even for the stuff that's not memory hungry, I'm paying for it.
Yeah.
And there's absolutely no benefit for me to keep it together. It's cheaper to separate it out.
Yep.
So the economic incentives are pushing me to kind of split it out. The deployment infrastructure, the way it's done now, is, for example, on Lambda, you have a total of 1.5 gigabytes of deployments for a particular function. So if I bundle lots of different things together and my deployment package is 100 megabytes, I can only do 15 of these and I'm done. Then I have to kind of redeploy, rewire, and reconfigure the whole thing, which is cumbersome. So the economic incentives of that are pushing me not to create a package of 100 meg.
Yeah.
They're pushing me to create 20 packages of 5 megs so I can kind of spin off different versions. And with the whole thing, what's also really, really interesting is they've done multi-versioning out of the box properly. So
really?
Every single deployment has a numerical version. They're all live forever. So by deploying a new version of a Lambda function, I'm not killing the old ones. They are still there. So
for people who are trying to version services.
That's kind of fantastic. And you know, multi-version is one of those things where people have been saying for years how if you want to do continuous deployment, you need to do multi-versioning properly. You know, other people are going to access stuff on all clients. We had this problem early on when we launched MindMap where we noticed people getting exceptions on the clients for some weird reasons, and then we realized that some mobile phone networks will cache HTML for about 2 weeks and not cache JavaScripts. So you have an old HTML file being served as depending on kind of old JavaScript, where meanwhile we've redeployed it 10 times and it no longer works. Now, maintaining that, you need to build your own stuff, you need to figure out how to do it, and kind of, okay, with JavaScript, fair enough, it's easy, it's files. What about backend services? Who keeps old versions of backend services, you know, live? Well, with Lambda, you can do that trivial. It's done for you. You don't have to do anything. It's there.
That's awesome.
It's more difficult not to do it than to do it.
Yeah.
And it's pushing people to create really good architecture. And I think that's kind of that's why I'm so excited about this.
Well, that's fantastic.
The economic incentives are making people do stuff they should be doing in the first place instead of fighting them.
Which is different, isn't it?
Yeah.
And it's nice that then it's able to, so it scales really easily and you get all those other benefits, but it's also saving you money at the same time.
Absolutely, yeah.
Awesome. Now, if I wanted, so it sounds amazing, but if I wanted to go and I wanted to get into serverless, what's the best path for me?
So I'm going to kind of do a shameless plug here.
Go right ahead.
And when we started migrating the MindMap backend from Heroku to Lambda, where it is now, the first thing that we did was this much code.
Yep.
And it was like, oh, is this it? Is this now how we're going to do stuff? This is amazing. And we're excited for about 10 minutes, and then we try to deploy it. And the thing is, the code is this big, but the deployment script was this big.
Oh, really?
Because it's, in order to be so generic and so good and so well and so good for so many cases, the deployment is really, really flexible.
Yeah.
So I have to learn a lot of things, and kind of our first deployment script was about 150 lines of shell scripts. The second one was that, and by the third time we realized that we can't keep changing these shell scripts all the time. So we created a small open source tool now called Cloudya.js that helps people have a function like this and deploy it with a single command line.
Oh, awesome.
So Cloudya.js is where I'd kind of send you to kind of look at that. We have a bot builder for chatbots for Slack, Facebook, Twitter, and not Twitter, Slack, Facebook, Skype, Twitter is going to be in the next version, and Telegram that allows you to do a chatbot this big and deploy it to all the 4 platforms.
Wow, that's
great. And scale it on Lambda and things like that. So that's one part. The other thing that people might want to look at is serverless.com. Serverless is a framework that kind of abstracts away the actual cloud you're working with. So if you want to kind of deploy to Azure and Lambda and kind of other things, you can use serverless. It's a lot more magical than Cloudya is. But it's more flexible, and there's Apex, that's another kind of deployment tool where it can do some really interesting things like deploy binaries. So for a while, Lambda was running in terms of JavaScript on Node 0.10, which is ancient, but with Apex you can deploy a new Node runtime and kind of use features that are not there. So those are the three things that people should investigate if they're looking at this.
That's awesome. Well, that's really exciting. I can't wait to check it out and start using it. Gojko, thank you very much for joining us.
Thank you very much.
And thank you for joining us at SSW TV.
Hey everybody, it's me, Scott Hanselman, here with Adam Kogan at NDC Sydney. We're hanging out at SSW Video. How are you, sir? That's how you do an intro. No, go ahead. I'll be right here, please.